Okay, welcome back. This is the second video. So all I did before I cut from the last video was just make these markings of parallel. I think my pen is like starting to die on me, which is making me sad. There we go. So C and D is parallel to each other, and E and F are parallel to each other. So in my given, so I'm gonna do some squiggles over here. It's going to be a little bit of a long proof. Remember, when you use supplementary, you got to use measurements of the angles. So C is parallel to D, and E is parallel to F. I'm going to just put both my reasons, and I'm not going to write the word statements above because I'm running out of room. This is given. So number 2, I'm going to talk about my corresponding angles at the same time. So 2 and 3 are corresponding angles, 1 and 4 are corresponding angles. So to save myself a little bit of room, I'm going to write them on one step. So angle 2 is congruent to angle 3, and angle 1 is congruent to angle 4. This is by the same postulate, so I can write them on the same line, which is corresponding angle postulate. So since they're congruent, I can do that. Now, also by definition congruence, because I'm going to have to do some measurements, I'm going to look at this. Angle 3 and angle 4 are supplementary. So angle 3 and angle 4 are supplementary. So what I'm going to do is come up here and say linear pair postulate, because it's a linear pair. Okay. Number 4, I'm going to use definition of supplementary, so I'm going to say measurement of angle 3 plus measurement of angle 4 equals 180 degrees. So that's definition of supplementary. Number 5, I'm going to talk about their measurements being equal. So measurement of angle 2 is equal to measurement of angle 3. Measurement of angle 1 is equal to measurement of angle 4. That's definition of congruence. So I'm using the definition of congruence, so knowing that the segments, or excuse me, the angles are completely congruent to each other, their measurements are equal. Now I have 2 and 3 being equal, 1 and 4 being equal, so I'm going to substitute those single values in. So number 6, measurement of angle 2 plus measurement of angle 1 equals 180 degrees. I know I'm doing a double substitution, but since I'm substituting out single values, it's not like doing two transitives. I'm just substituting out at the exact same time. So you could do 2 steps for this and have it in 7, but I'm going to do it in 1 step. So this would be substitution, property of equality. Now that their measurements add up to be 180 degrees, on step 7, angle 1 and angle 2 are supplementary. And that's using the definition of supplementary. So once again, it's a 7-step proof. If you break certain things out, it can even be longer. So you got 1, 2, 3, 4 steps that you can break out. So it's technically like roughly 11-step proof if you go line for line for line. But you got to make sure that when you use supplementary that you're saying the measurements add up to be each other. Alright, last but not least, we got number 6. Number 6, we have T is parallel to S, and angle 1 and angle 2 are congruent. What we need to prove is that angle 2 and angle 4 are congruent. So, looking at this, we got some pretty awesome numbers going on. 4 doesn't have, we have a few different ways we could do this, so we're going to look at it and we're going to solve it out. So to start, we're going to do given T is parallel to S, Angle 1 is congruent to angle 2. Step number 1. That's given. Okay. So 1 and 2 are congruent. So angles 3 and 4 are congruent, because we need to get 2 and 4 to be in the same line. So angles 1 and 4 are congruent, 2 and 4 are congruent. Angles 1 and 4 are congruent by alternate interior angles. So we could do this in 2 different ways. The first way, angle 1 and angle 4 are congruent because they are alternate exterior angles. So that's the alternate exterior angle theorem. Since 1 is congruent to 2 and 2 is congruent to, 1 is congruent to 2 and 1 is congruent to 4, I can do the transitive property. So step number 3, angle 2 is congruent to angle 4. So that would make that the transitive property of congruence. So technically I'm done. Another way you can do it is with vertical angles. So here, instead of doing angle 1 is congruent to angle 4, I'm going to do the proof over here off to the side. Same thing. So T is parallel to S. Angle 1 is congruent to angle 2. That's given. Okay. Angle 1, so that's step 1. Oh, that's a really bad step 1. Hold on. Try that again. Step number 1. Step number 2. Angle 1 is congruent to angle 3. These are corresponding angles, so corresponding angle postulate. Angle 3 and angle 4 are congruent. Angle 3 is congruent to angle 4. Those are vertical angles, so vertical angle congruence theorem. Since 1 is congruent to 3 and 3 is congruent to 4, I could do angle 1 is congruent to angle 4 by transitive property of congruence. Or I can work backwards with angle 3. This line could really be whatever you want it to be. So actually, instead of doing alternate interior angles, well, it's actually just going to be a bunch of transitives. So angle 1 is congruent to angle 4. Or you could say angle 2 is, or sorry, 1 is congruent. You could say 2 is congruent to 3 here, or 1 is congruent to 4. That's transitive. And then 5, 1 to 4, 1 to 2, angle 2 is congruent to angle 4, and that's transitive again. Once again, if I wanted to, this could be angle 3 is congruent to angle 2, and then I could say angle 2 is congruent to 4. So this one here could be changed up, but it's pretty much you can do a few transitives using corresponding angles postulate and vertical angle congruence theorem, or if you want to be pretty quick, alternate exterior angle theorem. So there's your proofs.